Welcome to lesson 5.1, writing linear equations in slope-intercept form. So in our last chapter, we looked at a lot of different ways we can graph linear equations. Now in this chapter, we are looking at how we go through the process of writing the equations based on given information. So obviously in this lesson, we are looking at writing the linear equations in slope-intercept form. So a reminder that slope-intercept form is always in the form y equals, so y is on its own, y equals m times x plus b. And the m, the part that's multiplying by x, is always your slope, and then the b is always your y-intercept. So based on the given information in example 1, they're giving us the slope and y-intercept and just simply asking us to write the equation in slope-intercept form. So we're filling in m and b. So in part A, our slope is 4, y-intercept -3. Slope gets attached to x, and then the y-intercept's on its own. So if it's a -3 instead of +3, we would have a -3. So y equals 4x minus 3. In B, we have a slope of 1/3, y-intercept of a +7. So our equation would be y equals 1/3 x plus 7. We could also write this as x over 3 plus 7, same thing as 1/3 times x. In part C, slope of -3, y-intercept of -1. So the slope gets attached to x, y-intercept on its own. So our equation, y equals -3x minus 1. And our last one, part D, slope is a -3/5, y-intercept +6. So y equals a -3/5 x plus 6. Then example 2 gives us a graph for our information. And based on the graph, they ask us to identify the slope and the y-intercept and then to write the equation. So in this case, we need to pull our information off the graph. What I would always start with is finding your y-intercept. So finding where you cross the y-axis. So in example 2a, we cross at a -2. So b, our y-intercept, is -2. Then you want to look from the y-intercept, how far did you have to move up or down and over to the next point? So from our y-intercept to the next point on the line, it was up to right 1. And we can tell from that point up to right 1 is the next point. So if we're moving up to right 1 to get to the next point, our slope would be 2 over 1, or just 2. So our equation would be y equals 2x minus 2, or 2 over 1x minus 2. In B, find your y-intercept first. So we're crossing the y-axis at -1. So B is a -1. From the y-intercept, we're going to follow the line to our next point. So it would have been down 1 and right 1, 2, 3. So down 1, right 3 gives me a slope of a -1 over 3. It's a negative because we're going down. The up or down's on top, and how far over is on bottom. So then same scenarios with C and D. C is just more zoomed in. Our origin of 0, 0 is right here. So we're crossing the y-axis at a +1. So B is +1. And then the slope to the next point would be up 1, right 1, to see where the line crosses again. So our slope is 1 over 1. So it would be y equals x plus 1. And then in D, we cross the y-axis at a -4. So our y-intercept to B is -4. From that point, if I'd go down to right 1, it looks like it's going to hit here, but I'm not positive because of that arrow. So I'm going to go in reverse, and I'm going to look along this line to see where it crosses at another point I can see, which is right here. So between this point and this point, it's down 2, from here to here, down 2, right 1. So either way, down 2, right 1, down 2, right 1. Our slope would be a -2 over 1. So then our equation would be y equals -2x minus 4. And then we get into kind of the newer piece, not as much of a review from last chapter, which is writing the linear equations from the given situation. Then use the equation to make a prediction. So in this case, they told us in 1990, California had a population of 29.76 million. So I'm starting in 1990, beginning population at 29.76. So where I began, I can think of that as my y-intercept or b. During the next 15 years, the population was expected to increase about 0.31 million people per year. So the part that's the rate, like people per year, miles per hour, dollars per pound, whatever's the rate, that gives you a hint that that number is going to be your slope. So 0.31 is my slope, or m. So the constant, the starting number on its own, tells you the y-intercept. The rate tells you the slope. And then it's asking about what was the population in 2005, so 15 years later than 1990. So my original equation is y equals 0.31x. So I'm writing this in y equals mx plus b, so my slope, 0.31 times x, plus the 29.76 for the millions of people that we began with. So then, over the next 15 years, we're going to predict what would be the total population in 2005. So we'll be putting the 15 in for x. So 15 times 0.31 is 4.65, plus the 29.76 tells us the approximate population in 2005 would be 34.41 million people. And then same thing in part B. Tells us a phone company charges $3.44 for the first minute. So that is our constant. No matter what, if you're on that phone for a minute, you're paying $3.44 just to make that call. Then it's 24 cents for each additional minute. So our rate would be 0.24, which is our slope. How much would a 9-minute call cost? So our original equation would be y equals 0.24x, slope attached to x, plus the $3.44 for that first minute. So then we're going to substitute a 9 in for x. 9 times 0.24, 2.16, plus 344 gives us 5.6. So that tells us the 9-minute call would cost $5.60. In our last example, example C, mosquito population currently estimated at 27.8 million mosquitoes per square mile. Okay, that's a rate, but it's telling us where we're currently estimated. So the current estimation tells me this number is my beginning point. So that's my y-intercept in my equation. I'm beginning already at 27.8 million mosquitoes. A spraying program will decrease, and that's a key here, will decrease the number of mosquitoes by about 1.8 million mosquitoes per square mile every hour. So there's our slope of 1.8 million. But because it's a decrease, that is a negative 1.8 because we're losing that many that many millions of mosquitoes every hour. And this is effective for the first 12 hours. Predict the mosquito population after 5 hours of spraying. So our original equation is y equals the negative 1.8 times x. For the 1.8 million, we're decreasing every hour. And then it'd be plus the 27.8 million that we began at. So then we're going to put in the 5 hours for x. Negative 1.8 times 5 is a negative 9. So negative 9 plus 27.8 leaves us with 18.8 million. So after 5 hours of spraying, we're expecting that mosquito population to be down from 27.8 to 18.8 million.